This is worksheet 8C, and we're going to start at the top here. We're given this equation, y of t, and it still is representing the height, and it has an initial velocity. This v of 0 is the initial velocity. We're going to change that to 50, and we're going to change g to gravity. So we have A, and we want to substitute our v of 0, which is 50. So we have y of t is equal to 50t minus 1/2. And we're going to substitute our g, which is our gravity, 9.81 meters per second squared, times t squared, and this is in meters. All right, we did A. That's really all A is. But this would be standard form. Negative 4.905 t squared plus 50t. B. B is asking me to find the velocity, which means they want me to take the derivative of y of t. We've already discussed that. V of t is equal to y prime of t, which is equal to, I bring the 2 from the exponent forward, I multiply that back out, and I'm just going to go back to negative 9.81. Because I move the 2 in front, and t to the 2 minus 1 plus 50, because the derivative of t, we already said, is 1. Okay, we found the velocity. All right, that was easy. Now, C, I want to find the acceleration, which is equal to the derivative of the velocity, which is equal to the second derivative of y of t. And all those notations are exactly the same. I actually like those notations better often, but not right this second. Right now, it's easier just to do the shorthand version. And this is going to be negative 9.81. And then the t becomes 1, so that's it. And 50, because it's a constant, becomes 0. All this is really telling me is that my acceleration has only to do with gravity. That's the only thing that is happening here, is because negative 9.81 meters per second squared is gravity. This is meters per second. That was easy. That was easier than the last worksheet. D, the time required to reach the maximum height, as well as the corresponding height, y max. When I want to find the maximum, if you remember from the last video, I think it was the last video, what you want to do, obviously this is a quadratic equation, so we're going to have and actually this is starting at 0. At 0, it is 0. And then it's going to be a parabola facing down. We're trying to find the maximum. And again, remember the maximum has a tangent line that's horizontal. The first derivative of y of t is y prime of t. We're going to set that equal to 0. And my y prime of t is equal to minus 9.81 t plus 50. And that gives me t equals 50 divided by 9.81. By the way, this is a terrible way to write a fraction. You should never write a fraction with a decimal in it. This is 5.1 seconds. I'm going to plug that in to my y of t. So this is going to be 50 times 5.1 minus 1/2 times 9.81 times 5.1 squared. I got 127.42, which should be in meters. This is my y of t max. That's the maximum height. And then I just want to sketch y of t. Let's see what I can do for a sketch. 25 seconds. 1, 2, 3, 4, 5. And I need y max is 127. So I can just make like 350, 100, 150, and 1, 2, 3, 4, 5. I'm going to need some more spaces here. 6, 7, 8. I know that at 5.1 seconds, I'm at my maximum, which is 127. So I'm going to say that's my max. That just tells me the vertex. I really need to graph it somewhat properly. I need my zeros. I'm going to go back to the original equation. I have y is equal to 50t minus 9.81 t squared. First thing I'm going to do is I'm going to factor this. And how I can factor it is I can take out a t. When I take out a t, I get 50 minus 4.905. If I set this equal to 0, I can find my x-intercepts, which is one thing I really need to do. And I do know that one of my x-intercepts is at 0. I can also tell because, parabolas are symmetric. So the distance from here to here in the x direction is 5.1. Since it's symmetric, it's going to do the same thing in the other direction. I don't even have to figure it out. Let's do this. Let's just extend this. 5.1 plus 5.1 is 10.2. So that means I need to go a little bit further. 9, 10. There's my sketch of y of t. Remember, I know that the vertex is always in the center. It's the axis of symmetry. If I have one of my t's at 0, which is what that says, if I divide the other one, we can see that 50 divided by almost 5 is going to be about 10. It should be about 10.2. That's how I found my other y-intercept. And that is the graph of the function.